Hey everybody, I'm going to take you through page 68, 69, and 70 in the packet. Watch this video and just fill in the blanks on some of those some of these pieces on 68, 69, and 70. So all they're asking you to do on these pages is give some reasons for other conclusions that you can make from statements that come from up above. So like in this first one here, let's get going. We know that t is the midpoint of xm, that's given. So then they're saying x to t is the same length as t to m. So when the word exists, most of the time the reason is definition. So put definition of midpoint for the first one here. Let me be with you just in a second here. Def of midpoint. All right. Numbers 3, 4, this next group, JC is equal to 2S. All that's changing here is that the equal sign is changing to a squiggly, and you're getting some other notations above the segment names. That's definition of congruence. That's kind of a cosmetic one. Definition of congruence is always used when equal signs change to squigglies or vice versa. Number 3 here doesn't have a picture, so if you draw a picture, what they're showing you here is D is on the interior. So D is somewhere inside the angle. The angle's A, B, C. And then they're saying that, oh, the big angle ABC is made up of two smaller angles. That's angle addition postulate. Angle addition. All right, going on to the next set on page 68. Yeah, this one, it's all you're doing is getting rid of the squiggly from there to there. Definition of congruence. Next one is just switching left to right. All it's doing is swapping left to right. That's symmetric property. And the last one here on page 68 starts out with a pair of complementary angles. And the one thing to notice is that the complementary angles share side DC. They share the vertex and one point on the ray to C. So saying that they're adjacent, you're just satisfying the definition of adjacent. So if a term is used, oftentimes it's the definition of the term. But then statement 4 switches to the number 90. Well, number 90 comes from this word complementary, so this would be definition of complementary. So definitions allow us to place words. They also allow us to place numbers. Okay, flip into page 69. Page 69. Let's do this while the sub's in class. So in 69 and 70, a little bit more intense because you have to actually make a second conclusion off of the givens. So if all they're told is that measure of angle 1 equals measure of angle 2, then we can conclude angle 1 is congruent to angle 2 by the definition of congruence. All right, definition of congruence there. The next one, let's switch colors here. If we know that angle 1 and angle 5 are 90, we can conclude complementary, because that's what 90 means. Angle 1 and angle 5 are complementary. We have satisfied the definition of complementary. Oh, what just happened there? I don't know what just happened there. Definition of complementary. Sorry about that glitch. All right, two conclusions we can pull off a linear pair. Angle 1 and angle 7 form a linear pair. A couple things we know about linear pairs. We know that linear pairs are supplementary. So angle 1 and angle 7 are supplementary. That's the definition of linear pair. Now, we also know that angle 1 plus angle 7 is equal to 180 by the definition of supplementary. So a couple definition conclusions there. What can we conclude about linear pair? What can we conclude about the word supplementary? If angle 8 is a right angle and angle 9 is a right angle, then we know that the measure of angle 8 equals 90, and the measure of angle 9 equals 90. That's by definition of right angle. And then we also know that the measure of angle 8 equals the measure of angle 9 by the transitive property. They're both equal to 90, therefore they're equal to each other. Let's see. If we know that 4 and 7 are complementary, what does complementary mean? That means that angle 4 plus angle 7 equals 90. We're using the definition of complementary. This one, just using a definition of congruence, measure of angle 1 is equal to measure of angle 7. Not much we can squeeze out of there. Just change the way our symbol looks. Number 7, on the last one on this side, if we know that 1 and 4 equal 180, what word can we replace 180 with? We can replace it with supplementary, because we've satisfied the definition. So the definition allows us to bring words in. The definition also allows us to get rid of words and bring numbers in. So look, a lot of these are definitions, okay? Because if we satisfy a definition, we can make another conclusion. All right, let's move over to the other column. Let's see what we can pull out of those. Let's go a little bit of that. If we know that angle 8 and 9 are vertical angles, so a picture of that would be like this, 8 and 9. What do we know about vertical angles? We know that 8 and 9 are congruent. And that's because the definition of vertical angles. All right. And then we know that the measure of angle 8 equals the measure of angle 9. And that's, we're just getting rid of the squiggly there. So that's just definition of congruence. Sorry about that glitch. All right. If we know that 3 and 8 are supplementary, we kind of had one like this on the other column with complementary. We know that the angle 3 plus angle 8 equals 180, because that's what supplementary means, so definition of supplementary. If 8 and 10, are both complementary to angle 7. Okay. Here's what we know, and this is kind of the transitive property. Angle 7 is the link. We know that angle 8 is congruent to angle 10, transitive. Number 11 is just like number 9. Angle 1 plus angle 2 equals 180. Definition of supplementary. Okay. Let's see, keep checking in here, Moving down to number 12. Okay, but this one's just the same thing. Angle 1 plus angle 5. They're kind of hitting this one a lot, 180. Definition of supplementary. ABC is a right angle, then we know it's equal to 90. Because that's the definition of right angle. DB is equal to SG. We're talking about a couple of segments, so let's turn them to segments and switch the symbol to congruence. And just go definition of congruence. H and P form a linear pair, then we know that angle H and angle P are supplementary. Because we have satisfied the definition of linear pair. And then we know that angle H plus angle P is equal to 180, because that's the definition of supplementary. This one is a lot like number 3 over on the other side of the page, or other column of the page. Okay. All right, last ones. You can flip to page 70. Here we go. Let's finish it up here. Math. This one's a little bit like on the previous page, number 14. We're just going to take away the congruence, or sorry, this one technically should have a squiggly up above there. So this one is just definition of congruence. Not much you can do with that one. Let's see. So we're going to use transitive property first. Say the measure of ABC is equal to the measure of JLM because they're both equal to 147. You could call that substitution, but I think it's just as easy to call it transitive. They're linked together with the 147. And then we're going to put the squiggly in and call it def of congruence. So def of congruence does a little bit. Let's just use transitive here. FG is the link, so say TI is equal to SD. Let's go transitive on that one. You could go def of congruence then for another statement off of this one, but I like just doing transitive on that one. All right, moving on down to number 19. Then we know the measure of angle DMB equals 90. We had one like this earlier, def of right angle. So most of the time when you see a word, your next conclusion is going to be based off the definition of that word. 3 and 7 are complements, 6 and 7 are complements. I'm going to say angle 3 is equal to angle 7, or is congruent to angle 3 is congruent to angle 6. Since angle 7 is in both these statements, that's kind of a transitive property thought. Sorry for the glitch. See if I can get us back here. Yep, transitive right there. All right, and then we can get rid of the squiggly by saying def of congruence. All right. I see transitive here. I see these two angles are the same. So I'm going to know that angle QWE is congruent to angle WSZ, transitive. So transitive works with complements and supplements. If your supplements are the same angle, you're congruent to each other. If your complements are the same angle, you're congruent to each other. And then we can get rid of the squiggly and bring in the measure. Def of congruence. I don't know why I didn't capitalize it there, but this one transitive again. I see the 30s there, so you can say measure of angle 7 equals measure of angle 8. Transitive. So transitive gets played a lot in these few problems here, 3 in a row that have transitive. And then you can put the squiggly back in. Say angle 7 is congruent to angle 8, and that would be def of congruence. All right, moving on to the last 3. All right, the other column. Let's put an equal sign. Def of congruence. Sorry for the glitch there. Oh, wow, look at number 24. I'm seeing a big transitive here. DC links, then EF links, then GH links. So let's say AB is the same length as IJ. It's like transitive a couple of times. Just call it transitive. Link, link, link. All right, we had one like this earlier. We know if we know those are both right angles, then we know that their measures are both 90, definition of right angle. TUV equals 90, def of right angle. And then we know that they're congruent to each other by transitive. Since they're both equal to 90, they're equal to each other. All right, that's all I got here. So copy this down and then also do that quizzes for today.